You know, in the world of Go programming, there's this one error handling mistake that almost everyone makes. It looks totally harmless, but it's really a disaster just waiting to happen. So to get to the bottom of it, we're going to follow the story of two developers, Eleanor and Ethan, and see how a piece of code that passes every single test can still be fundamentally and dangerously wrong.
So picture this. Your junior colleague, let's call him Ethan, shows you some code. And hey, it works. It does the job. But you, playing the role of the senior engineer, Eleanor, you take one look at this one specific line and you say, that is a ticking time bomb. So what could possibly be so bad about code that, for all intents and purposes, seems to be working just fine?
And that's really the heart of the issue here. Ethan's totally confused. I mean, his code does what it's supposed to do. It returns a 404 not found when a database record is missing. All the unit tests are green. So why is it a time bomb? Well, this is where we learn the difference between code that just works today and code that's actually robust and built to last.
The whole problem boils down to something called the brittle string trap. You see, Ethan's code relies on checking the literal text of an error message. It's a really easy mistake to make, but trust me, it's a recipe for one of those 3 a.m. production alerts that we all absolutely dread.
Okay, and here it is. This is the line that's causing all the trouble. Ethan is using the strings.contains function. He's literally just checking if the error he got back from the database includes the phrase record not found. If it does, he just assumes, okay, that's a 404. It's simple, it's direct, and it's incredibly fragile.
And this is exactly where it all falls apart. Today, the database driver's error message is in fact record not found. So the code works perfectly. But what happens next month? What happens when you update a library? The people who wrote that library might decide to change their error message to something a little more standard like no rows in result set. Now your code hasn't changed at all, but it is now silently, completely broken. So here's the chain reaction of doom. Today, everything's great. Tomorrow, you do a routine update and that little error string changes. All of a sudden, your check fails. Your app no longer sees this as a not found error, it just sees some generic unknown failure, and boom, it defaults to a 500 internal server error. And that is when your pager goes off in the middle of the night. Okay, so how do we fix this? How do we avoid this trap? We have to stop thinking of errors as just plain text and start treating them like a programmable state. And that brings us to our first really big concept for robust error handling in Go, something called sentinel errors. So what is a sentinel error? It's really just a special variable that a package exports to represent a very specific kind of failure, like db.errNotFound. It stands guard, which is a great way to put it. It gives you a stable, reliable target that you can check for, instead of, a flimsy string of text that could change on you at any time. Let's just put these two approaches side by side. The old, brittle way relies on a fragile string. The new, robust way uses a function called errors.is to check if the error we got is, fundamentally, our sentinel error, db.errNotFound. Now this check doesn't care about the text. It relies on the variable's memory address. So even if the error message changes, the check still passes. This thing is rock solid. All right, problem solved. We're using sentinel errors. We're good to go, right? Well, not quite. Just as Ethan implements his fix, he realizes, oh, I need to add more context to my errors. Like which user ID failed to be found. And this new requirement, it introduces a whole new trap. A really subtle one, but just as dangerous.
Right, so the goal is to return a helpful error, something like failed to find user with ID 42, but, and this is key, without losing that original error not found information. The most intuitive way to do this, using the standard formatting functions, can accidentally undo all of our great work.
Okay, this is probably the most crucial technical point. If you use fmt.erf with the standard %v verb, you are creating a brand new error. It just takes the original error, flattens it into a simple string, and poof, the sentinel is gone. It's destroyed. Your errors.ice check is now broken. But if you use the magic %w verb, you wrap the original error, preserving it inside the new one.
This whole idea of wrapping, it's a genuine superpower in Go. And the source material uses this perfect metaphor for it. A matryoshka doll, the Russian nesting dolls. Every time you wrap an error, you're just placing it inside a new, slightly bigger doll that adds a little more context. Let's just walk through how this works. At the very core, the smallest doll is your original sentinel, db.errNotFound.
Then, the database layer wraps it to add the user ID. That's the next all. Then, maybe the HTTP handler layer wraps it again to add its own context, and now you have this beautiful chain of errors. And the best part? When you call errors.is, it automatically opens up every single layer of that DAL looking for the original sentinel that's nested deep down inside. It's brilliant.
You know, all of this really leads to the most important insight of all. We have to fundamentally change how we think about errors. An error in Go isn't just some text that's destined for a log file. It's a rich, structured piece of data. It's an API.
Eleanor's final piece of advice really just puts everything into perspective. She says, an error is an API. You are designing a programmable interface of failure states. Build it so the machine can read it reliably, using sentinels, using wrapping, and the human-readable part, the helpful log messages, that'll all just fall into place.
So, I'm going to leave you with this question. Go take a look at your own projects. Are you falling into that brittle string trap? Are your errors just plain old text? Or are they a well-designed, robust API that lets your program make smart decisions when things go wrong? Because that's the difference between a system that fails gracefully and one that wakes you up at 3 in the morning.